How do we describe preferences? Well, it's really useful to be able to draw a picture of them. So this is where sticking to two goods is very helpful. We're going to use the idea of an indifference curve. So pick some bundle A, and then draw a curve through all the different bundles where the consumer is indifferent between that bundle and bundle A. This is what we call the indifference curve through bundle A. The assumptions we've made on preferences, like transitivity, completeness, and monotonicity, are going to restrict what that indifference curve can look like. So to understand what monotonicity says about indifference curves, let's look at this picture here. So we've got the quantity of good 1 on the horizontal axis and the quantity of good 2 on the vertical axis. So let's look at this bundle E. It has a certain amount of good 1 and a certain amount of good 2. Now E has less of every good than bundle F. So what monotonicity tells us is that F has to be better than E, because F has more of good 1, right? How much of good 1 does it have? It has this much good 1. How much of good 2 does it have? It has this much of good 2. So it has this much more of good 2, this much more of good 1. So it has more of both goods, therefore monotonicity says it has to be better than good E, bundle E. Now that's true of every bundle in this region here. Anything that's above this dotted line and above this dotted line, anything in this region would have to be better than E for the same reasons. It has more of both goods. Now, by the reverse argument, E has more of both goods than D. D only has this much of good 1, and it has only this much of good 2. So E has more of both goods than bundle D, and therefore monotonicity says E has to be better than D. In fact, that's going to be true of any bundle in here. So everything in this shaded region has to be worse than E, or E has to be better than any bundle in that area. So what we know then is that the indifference curve through E cannot pass through this region where F is, because all those bundles are better than E. It can't pass through this region where D is, because all those bundles are worse than E. Now what about this bundle A? A has more of good 2, has this much more of good 2 than bundle E. However, E has this much more of good 1 than bundle A. So A may be better or worse than E, or you could be indifferent between them. So by the same reasoning, we can't really say whether any other bundle in this unshaded area is better or worse than E. So the indifference curve would have to pass through that unshaded area. So perhaps it passes through A and B. This is just one example. It doesn't have to pass. Monotonicity doesn't tell us that. All monotonicity tells us is that it would have to pass through that unshaded area, and it wouldn't be able to pass through bundles like D and F. It would have to pass through bundles like A and B. Whatever indifference curve passes through E has to pass through bundles like A and B, and not bundles like F and D. It could have just as well passed through C instead. So this indifference curve, which we'll label I1, is composed of all the different bundles that the consumer is indifferent between when compared to E. Now we could draw an indifference curve for every possible bundle. That's going to give us a whole bunch of different indifference curves. So perhaps we could label them indifference curve I1, that's the one through D, I2 passes through C, I3 passes through A, E, and B, I4 passes through F, and so forth. This collection of indifference curves is what we call a preference map. Now, what are some properties of these things? Well, because of this more is better principle, or monotonicity, we know that these indifference curves are passing through better bundles as you move to the northeast. We also know that there's exactly one indifference curve through every bundle. We'll see that indifference curves can't cross. Indifference curves have to slope downwards. They can't be thick. So let's see why this is the case. So first, let's think about the possibility of crossing indifference curves. So let's suppose you have this bundle E, and there are two different indifference curves that pass through it, I1 and I2, and they cross at E. Well, if they cross, then I would be able to find a bundle A on I2 and a bundle B on I1, such that B has more of both goods than A. Now, E and B are on the same indifference curve, I1. So by definition of an indifference curve, the consumer is indifferent between E and B. Second, E and A are on the same indifference curve, I2. So by the definition of an indifference curve, by definition of indifference curve I2, E and A are indifferent. Remember that we've assumed that preferences are transitive. That means that since E is indifferent to B and E is indifferent to A, these two have to be indifferent to one another. So the consumer is indifferent between A and B. Nonetheless, monotonicity says that since B has more of both of the goods than A, B has to be better than A. So we've reached a contradiction here. These two can't both be true. It can't be that B is better than A and the consumer is indifferent between them. It's one or the other. This is a typical proof by contradiction. So we've proven by contradiction that there cannot be a point where two indifference curves I1 and I2 cross. For if they did, we would be able to find an impossible situation where there's a violation of monotonicity. What about an upward sloping indifference curve? Is that possible? Well, if there were an upward sloping indifference curve, again we would be able to find an A and a B that were on the same indifference curve I1. And because this indifference curve is sloping upwards, B would have more of both goods than A. Again, by definition of the indifference curve I1, the consumer is indifferent between these two bundles because they're on the same indifference curve. By monotonicity, since B has more than A of both of the goods, B has to be better than A. Again, this is a contradiction. Those can't both be true. Therefore, it can't be that we have an upward sloping indifference curve. What about a thick indifference curve? Is it possible that we have a wide indifference curve? Very similar reasoning to upward sloping indifference curves will show that that's not possible. Suppose we did have a wide indifference curve, then we can find a bundle B containing more of both goods than a bundle A that's on the same indifference curve. By definition of being on the same indifference curve, you have to be indifferent between them. However, since B has more of both goods than A, B has to be better. Again, that's a contradiction. It can't be. Therefore, it couldn't be that the indifference curves were thick in the first place.